Alright, ladies and gentlemen, this is going to be the next video on carbohydrates. So let's get started on this next video. Let's go through, well, what is a carbohydrate? Well, some people might think of breads, like, oh, I can't eat too many carbs, I'm on a diet. Or some people are going to think of other, maybe whole grains, wheats, any type of grain. And some people are also going to think of sugars. As a scientist, I'm thinking about sugars. When I think of a carbohydrate, I'm really just thinking about sugar. And when I'm talking about breads or grains or any of that, remember, we're really just going down to the molecular level. And when we talk about carbohydrates, we're talking about sugar molecules and how our body's using them for energy. What is the function of a carbohydrate? Well, we have to think about this a little bit deeper. So this concept map should help you a little bit trying to understand that. The primary function of a carbohydrate is going to be, in this particular case, short-term energy. And we can take this short-term energy and we can use it via these sugars. Again, carbohydrates are just sugars. Now, the sugars are going to allow us to go through and produce ATP through cellular respiration. This is going to be a totally separate unit that we will go through and learn about this. But we're taking the sugars from the food that we consume so that way we can turn it into energy. Now, you can gain weight if you eat too many carbs because you're going to convert all of those sugars into long-term storage and fats. Now, the secondary function is also going to be really, really important. When we're thinking about carbohydrates, they serve a couple of different purposes in plant structure and animal structure. So they're going to support plant function and the structure of plants, and in some cases, they're actually going to support the structure and function in animals as well. But the secondary function is really to just provide a structure or a substrate that's going to allow plants to stay upright and allow those plants to grow against gravitational forces. So let's think about the word carbohydrate here and kind of relate it back to the polymer video that we've seen. Now, when I'm using the word monosaccharide, disaccharide, and polysaccharide, saccharide means sugar. So let's say I broke this word apart and I just took the A out of the carbohydrate here. Well, this would be similar to just a monosaccharide or a single sugar unit. We're pretending this entire word carbohydrate is in this case a long sugar chain or a polysaccharide. If I were to just take one of those monomers, it would be a monosaccharide. If I were to take two and put them together and bond them together, well, in this case, this would be a disaccharide. Mono meaning one, di meaning two. And remember, one sugar, two sugars, and that makes sense. It's like me taking two of the letters from carbohydrate, putting them together, and this would be disaccharide. Now we can also go through and put many together, and in that case we will call it a polysaccharide. So if we're thinking about this, monosaccharides consist of a monomer. A disaccharide and a polysaccharide are multiple monomers put together to create polymers. Remember, anything with two or more monomers is a polymer. So we're trying to relate this back to our polymer video that we went through and looked at already. So let's go through and try to delve into carbohydrates a little bit more. So if we're thinking about this, the general formula for a monomer is going to be CH2O with the subscript N. And that subscript is really going to be dependent upon if it's a pentose or a hexose. So we're thinking about pentoses. This is going to be carbohydrates that have a 5-carbon backbone here. So in this case, we can represent it with the model here. It's going to have 1, 2, 3, 4, 5 carbons linked, and in this case we call it a pentose because, again, pentagon, 5 sides. Pentose is referring to a 5-carbon backboned carbohydrate. Now we also have hexoses, which is going to have a 6-carbon backbone. So if we were thinking about hexoses, we would represent the model like this. We would have 1, 2, 3, 4, 5, and then 6 carbons in the backbone here. So this is significant because dependent upon whether we have a pentose or a hexose, it's going to have different functions in our bodies, and we can link these monomers together to create different disaccharides and different polysaccharides or different polymers of these two monomers. So we're going to look at glucose. Glucose is one of the most important molecules in your body because it's directly involved with the generation of energy and ATP in your body. And we can see it has 1, 2, 3, 4, 5, 6 carbons in its backbone, so therefore it's a hexose. So we have to think about monosaccharides as being a single sugar, or they're just a monomer. So if we go through and look at the image here, Any of these are going to be made out of a carbon, a hydrogen, and an oxygen with a 2-to-1 ratio. So in this particular instance, if we look at glucose here, we have C6H12O6. And in this case, we can see that we have a 2-to-1 ratio between our hydrogen and our oxygens. For every one oxygen, there are 2 hydrogens here. So what we can see here are isomers. And remember, an isomer is a molecule that has the same molecular formula, but a different shape. This is from the organic video. So if you don't remember, I would suggest that you go back a little bit. So if we look at this, we can see different types of sugars. In this case, I have 2 pentoses and 3 hexoses. And the names of the sugars are different because they're isomers of each other. So if we look at the hexoses, we have glucose, fructose, and galactose. But all of them serve different functions because they have different shapes. So in this case, glucose, it's in the blood. It's really the cell's main source of energy. Fructose gives the sweetness of fruit, and galactose is found in milk. Again, these are all hexoses, and they are all in this particular instance going to be isomers of each other, but they serve different functions. So we can also look at ribose and deoxyribose, and they're both found in RNA and DNA, but RNA and DNA have 2 completely different functions, and they serve 2 different purposes when we're talking about genetics. So let's go through and look at disaccharides then. Now, a disaccharide is going to be a double sugar, so it's going to be a polymer. As we look at this a little bit more, we can see something like glucose is represented with this model here. Now, glucose is going to be a hexose, and remember, it's a monomer. Now, if we take glucose and we add a fructose to it, which is also technically a hexose, this part of the video might be a little bit confusing. Technically, fructose, remember, it's an isomer of glucose. Its molecular formula is C6H12O6. But here's the thing. Fructose is what we call a ketohexose, whereas glucose is an aldohexose. Now, fructose technically has a 5-membered furanose ring, and it does have 6 carbons. They're not connected together in a hexagon-like ring. They're actually in a pentagon-like ring, and then we have a carbon that's going to stick out of this pentagon. But for right now, I represent the fructose with the green model here because it does have a 5-membered ring, but it technically is a hexose. So if we take glucose and fructose and put them together, remember we go through dehydration synthesis, we remove a water. What we're going to get is sucrose. And sucrose is a disaccharide that we put together between a fructose and a glucose molecule. So in this case, we're taking 2 monomers, we're taking our glucose and our fructose, and we're creating a polymer, a disaccharide sucrose. So just as a frame of reference here, and just so we understand if you guys see this word, a bond that joins monosaccharides together, or carbohydrates together, is what we call a glycosidic bond. So if we look at common disaccharides, well, we can see sucrose, lactose, and maltose. And really all these are just monomers that we put together, and then they create a larger polymer, a larger sugar that provides different functions. So if you have glucose and fructose, well, if we combine the 2 of them, we get sucrose, and that's kind of like table sugar, or sugar cane that you would see maybe in a can of Coca-Cola or on the table at dinner. Lactose is glucose and galactose put together. So this is important for generating milk in mammals and providing energy for suckling animals. And then we have glucose and glucose. If we put them together, we get maltose, which is basically malt and grains. And this is going to be derived from starches and cereals and pastas. But again, we're thinking here, we're taking 2 sugars, we're putting them together. We have 2 monomers, so we're going to get a polymer. And we use the word disaccharide, meaning that there are 2 sugars put together. So the last one that we're going to go through and talk about are polysaccharides. So a polysaccharide is basically any polymer that we're going through and talking about, or any saccharide where it has at least 3 monomers, or at least 3 monosaccharides that are part of it. So if we were to take, I don't know, let's look at this particular hexose here. Let's say that this was a hexose that existed in a plant, and we can say that this might be glucose in this particular instance. We can link 4 of them together, and then we're going to get a polysaccharide. And again, we're going to be forming these through dehydration synthesis, and the general formula for this is going to be C6H10O5 with the subscript N plus an H2O molecule. Remember, N is just the number of monomers that we're going to see in this particular molecule. We have to relate this back to enzymes. And enzymes are going through, and remember, they're going through and facilitating these chemical reactions, going from monomers to polymers, going from monosaccharides to disaccharides and polysaccharides, and then in the reverse. So we're thinking about the enzyme catalytic cycle here. Well, we can relate enzymes to the building and breaking down of polymers. So remember, an enzyme has an active site, and that active site is going to be specific for certain types of substrates, and then the enzyme is going to go through and make that chemical reaction occur. So in this particular instance, the first part is where we have the substrate. So let's say we have glucose and fructose again. They're bonded together, and we have sucrose, and we want to go through and convert that into the monomers. Well, this substrate is going to bind to the enzyme. We're going to form our enzyme substrate complex, and then that substrate complex is going to go through, and in this particular case, this enzyme is going to create stress amongst those molecules, and we're going to go through and remember, lower the activation energy, creating glucose and fructose. So the fourth step is where the products are released. The enzyme is free to bind to other sucrose substrates. We can reuse the enzyme, and now we get the glucose and fructose for whatever need we have in the body. Sometimes we need the sucrose put together, but sometimes we need the glucose and fructose separated from each other. So if we're thinking about common polysaccharides, well, common polysaccharides aren't going to be anything like glycogen, which is really just animal starch, cellulose, and starches. And cellulose is going to give strength and rigidity to plants. Starch is going to be a polysaccharide that stores excess sugars for plants. And then glycogen is going to store excess sugars in liver and muscles. And all of these polysaccharides are really, really important for biochemical functions. So if we're going through and talking about starches, well, starches are going to have this shape. And this is going to be the formula. Let's think we were maybe looking at a potato. If we were to zoom in, we could see that this is going to occur in grains or potatoes, and we can see that a starch is just the main storage of carbohydrate sources in plants. So amylose is an unbranched coiled chain, and amylopectin is a long branch chain of which some are coiled. So it's a monomer of alpha glucoses here. Now, if we look at cellulose, which occurs in fibers, well, cellulose is going to look like this. So we can see cellulose in plant fibers here. And we can zoom in and then go through and look at the specific fibers of plant cells here, and cellulose is going to be the main component of cell plant walls. So cellulose is a straight, long unbranched chain, which forms hydrogen bonds with adjacent chains, and it's a monomer of a beta glucose. Now, you guys don't have to understand what a beta and alpha glucose are until I explain it here. So an alpha glucose, well, that's going to have this shape here. And the linkage, we're going to see that all the hydroxyl groups are basically on the bottom of this polymer. Now, if we're talking about cellulose, well, cellulose, our hydroxyl groups are flip-flopped here. And we can see we have one on the bottom, then the top, then the bottom, then the top. Now, this is important because you can break down alpha glucose rings and structures and chains, but you cannot break down beta glucose chains here. So when we're talking about fibers, well, fibers are going to pass through your body. The reason that you're supposed to have fibers in your diet is because you really can't digest them, and they're beta glucoses that are all chained together in a polymer. The enzymes have specific shapes that allow you to go through and break down these polymers into the monomers. Now, you only have the enzymes to go through and break down alpha glucoses or starches, but you don't have the ability to break down cellulose, which are beta glucose monomers put together, because you don't have that enzyme on the right. So when we're talking about fibers, the reason fibers pass through your body is because you don't have the enzymes to go through and break them down. So did you guys learn? Well, did you learn a couple of things? Did you learn what a carbohydrate is? Did you guys learn the types of carbohydrates? And then did you guys get a basic understanding of starch versus cellulose? This is going to be the end of the video. I will see you guys in class tomorrow.